Solution to the Fermi paradox found. Scientists hope they're wrong. Where are all those aliens if the Earth isn't that important in the big picture? A group of researchers looked at the Great Filter theory, humankind's position in it, and our species' destiny to try to answer this question. In case you've never heard of the Fermi paradox, here's what it's all about. Since the Earth isn't the only planet in the universe, there's likely other life out there. So why hasn't anyone tried to make contact? Suppose there are numerous other civilizations. In that case, some of which may be much more sophisticated than us due to the universe have been around for so long. Why aren't they doing what we're doing and sending out spacecraft and obviously searching for other evidence of life? The Great Filter is one reasonable solution. The idea behind this theory is that before alien civilizations get to the point where they might leave their star system and start colonizing their galaxy, or even the whole universe, something stops them, or would see signs of this in our own Milky Way. We do not know if this is the following step from multi-cell life to animals that can utilize equipment, or the next step from where we are currently to discovering the galaxy. This is incredibly exciting, because we don't know if the Great Filter has already happened or will occur in the future. Is it possible that most things don't make it past the single cell stage, but we've already passed this filter? Or, like many other alien civilizations, are we going to destroy ourselves in order to leave the planet? This could happen through battle, or by using up all of our resources before we can depart. Enrico Fermi, a physicist who won the Nobel Prize, asked his co-workers, "Where are they?" in 1950. Fermi was thinking about how big the universe is, and when he asked, "Where are they?" he meant aliens. There are so many stars and planetary systems in the universe that it's hard to imagine there aren't intelligent civilizations out there that have developed radio astronomy and can travel between stars. Yet, back in Fermi's time, there was no proof of these kinds of civilizations, which is still the case. The Fermi paradox is the fact that there is no proof of life on other planets, even though the number says that there should be a lot of it. But there are no indications of alien technology, and our radio telescopes do not even grab voices from other realms. There have been numerous ideas about how to solve the Fermi paradox, but none of them have been proven. And during the 1990s, Robin Hanson came up with a theory called the Great Filter that could explain why it seems like we are the only ones in the universe. So, how hard it is to find life on other planets? Simply put, the Great Filter says that intelligent life, forms that live between stars, must first do a lot of important things. And at least one of those things must be very unlikely to happen. In fact, the Great Filter is based on the idea that at least one barrier is so significant that almost no species can get over it and move to the next barrier. But while the name Great Filter makes it sound like an outside force is at work, in fact, the hypothesis is merely a method for thinking about how likely it is that certain things will occur or not occur in their own time. So, what are the most basic problems that need to be solved before we can evolve into a genuinely sophisticated spacefaring society? Hansen gave a few examples. Let me tell you a few of them. A planet that could hold life should form in the habitable zone of a star. There has to be life on that planet. These organisms must be able to make more of themselves using molecules like DNA and RNA. Prokaryotes, which are simple cells, must change into more complex cells called eukaryotes. Multicellular organisms must establish complex organisms that can use tools and need to develop. These organisms must make the high-tech tools needed to settle in space. The species that can travel through space must continue to settle in other realms and star systems without ruining itself. Aside from some few spacecraft like the Pioneer, Voyager, and New Horizons, individuals are not yet capable of traveling between stars in a significant way. However, we can do sophisticated radio astronomy, which shows that we are a fairly tech-savvy civilization. If, however, the universe is as old as we think it is, there ought to be at least a few interstellar species that have colonized their entire universe now, even though it took them a long time to develop the same massive technological leaps as we have. But once again, astronomers don't see any signs of these kinds of societies. When they look up at the stars, they can't believe how quiet it is. The most difficult thing to do is to become a galactic civilization. The Great Filter is hard to find because, among many other things, the conditions on other planets are very distinct from those on Earth. This artist's idea shows what a planet in the TRAPPIST-1 system might look like from above. So, what might the Great Filter be? Well, maybe abiogenesis is extremely rare. Perhaps the Great Filter is the fact that this event doesn't happen very often. On the other hand, maybe life happens all the time, but the vast majority of life never gets past simple single-cell organisms. Perhaps there are a lot of bacteria in the universe, but bacteria don't construct spaceships. On the other hand, the Great Filter could be caused by technology. Maybe the most advanced civilizations tend to destroy themselves with some kind of a tech gone wrong, like a doomsday device, nanotech, or bad machine intelligence. Humanity is already very close to being able to kill itself in a global nuclear war. And unfortunately, it's feasible that these kinds of mass extinctions happen all the time in the cosmos. The Great Filter might also be an occurrence that has nothing to do with a species being tested, no matter how advanced they are. For example, the effect of a massive asteroid or rogue planet, a neighboring gamma-ray burst, or a forceful supernova could kill all life on Earth or any other planet. Although, if we knew these things were going to happen, we couldn't stop them with the tech we have now. Another probability is that the Great Filter is not likely to happen in more than one step. This would make it a lot harder for civilization to reach the level of technology needed to learn how to travel between stars. Has the Great Filter already been passed? If the Great Filter is gone, it's good news for human civilization as a whole. We could take over the universe, but we might be doomed if the Great Filter is still to come. On the positive side, some people think that the fact that we seem to be alone in the universe is a good indication, or even a blessing, because it means we've managed to make it through the bottleneck securely. Humans could be the first species to have to pass through the Great Filter, which may sound strange. After all, someone has to be first. On the contrary, if we picked a message from a species with much more advanced technology than us, it could mean that the Great Filter is still to come. Humanity might be fated to undergo a cosmic test that we have no idea how to prepare for. Yes, the Great Filter is just an idea. Although, from a logical point of view, it's an interesting idea that makes sense on many levels and could explain the Fermi paradox. So, we still don't have an answer to where are they, but the Great Filter theory represents one of the wild estimates we can come up with. But that does not answer the question of whether or not the Great Filter is already behind us. So, what do you think of today's episode? If you find this video informative, please make sure to like and subscribe. See you next time.